So let's do this example to illustrate the difference between some of the translational and rotational variables. So in this problem here, we're going to have a pen here and we're going to rotate it about its center like this. And consider, if you look at two different points on the pen, like say here versus here, do they actually have the same value of these different quantities as I rotate the pen? Okay. Question number one, do they have the same speed? Well, actually, do they have the same speed? Number two is the same velocity. Number three is the same angular velocity. We probably want to try to answer all three of these questions at the same time. What is the same between those 2 points? Is it the speed or the angular speed that's the same between the 2 points? So if you think about, there's a number of ways you might be able to reason your way to this, but one way to think about it is this way. Let's say that this pen rotates a certain amount. If you visualize it, the pen goes from, here, where it's shown, to like another state, like here, right? Notice that point A would only have to move a very short distance from here to here. So point A barely moves at all, but point B has to move a much larger distance from there all the way up to there. So you'll notice the distance traveled by B, the distance traveled by B is larger than the distance traveled by A, but they're doing it in the same amount of time. So since speed is basically delta x over delta t, that means that the velocity has to be, the speed has to be larger for A. Larger for B, because B goes a longer distance in the same amount of time. And if the speed is different, the velocity also has to be different because speed is part of velocity. So the direction of the velocity is actually the same for both, but the magnitude is different. So the speed's not the same because it's larger for B. The velocity is not the same because the speed's not the same, but the angular velocity is the same because the angular velocity has to do with how much this angle is changing. And the angle is the same for both. The actual distance traveled is different, but the angular distance traveled is the same. So, the distinction here is that V is delta x over t, omega is delta theta over delta t. The delta theta is the same for both, but the delta x is different for both. So as a result, the speed is different, but the angular speed is the same. Okay. What about 4 and 5? The acceleration and the angular acceleration. We don't exactly know that much. Well, actually, we do know that it's a constant rate of rotation. Let's take that into account as well. If there's a constant rate of rotation, that means that the tangential acceleration is 0. And it also means that the angular acceleration is 0. So first of all, the angular acceleration, number 5, is the same for both because it's 0 for both. What about the regular acceleration? Is that the same for both? The tangential part is the same for both. What about the centripetal part of the acceleration? The direction of the centripetal acceleration is the same for both because it points back towards the center of the circle. So the direction of centripetal acceleration would be this way for both, to the left. Is the magnitude of centripetal acceleration the same? No. Centripetal acceleration is v squared over r. V is different for both, r is different for both. Or if you prefer, an even clearer way to do it is actually centripetal acceleration is omega square r. Omega is the same, but r is different. So therefore, the centripetal acceleration is different. So acceleration is not the same because the centripetal part is not the same. But the angular acceleration is the same. And the tangential acceleration is also the same because those ones are 0. So you can probably see here This is really not very intuitive. You cannot answer these questions by just like going with your gut. You've got to actually think about precisely what are the definitions of these terms, and really go through it carefully to figure out exactly what's going on.